Let's derive the logarithm quotient rule. We're going to start off by setting up a couple of exponential equations. We got 10 to the a equals x, and we have 10 to the b equals y. And now from here, that's the same thing as saying that we have all the same information to say that log base 10 of x is equal to a, and that log base 10 of y is equal to b. And I use 10 as the base because as a convenient way to write log base 10, people just get rid of this 10 and say log of x, log of y. So you get rid of the x, you get rid of the 10, and it's just the shorthand. And so whenever you just see plain log, like up here, we have log of x over y, that's shorthand for log base 10. So it's just convenient and it keeps our work neat. It's important to keep out that this is true for all bases. This could be log base 68, it doesn't matter. This rule holds true for all bases. I wrote it like this because especially when you're getting started, it just helps kind of make things concrete. It allows you to like really visualize what's going on and not get lost in extraneous details. So next thing we're going to want to do is divide the left side of the equation. We're going to divide 10a by 10b, and the right side of the equation we're going to divide x by y and create that, make that form one single equation. So we can write 10a over 10 to the b, 10 to the a over 10 to the b equals x over a. And that's fine to do because it's the same thing as if we had say 10 to the a equals 3, well, x equals 3, so you have 3, and say 10 to the b equaled 5, and y equaled 5, so then that would be 5 and 5. So 3 over 5 equals 3 over 5. That's the same thing. We have 10 over a, 10 to the a power over 10 to the b equals x over y, and that's fine. And so another way to write this is 10 to the a minus b equals x over y. Well, we actually solved in terms of logarithms anyway. We solved for a up here. We have log of x equals a and log of y equals b. So let's replace that in here. We can rewrite this. 10 to the log of x equals a. Get rid of that, clean that up. With 10 to the log of x equals a minus log of y is equal to b. And then that's all equal to x over y. So if we take the logarithm of both sides of this equation, base 10 logarithm, so we have log base 10 of 10 to the log x minus log y. And that equals log base 10 of x over y. Then we can actually reduce this thing on the left-hand side. Logarithm and exponents are inverse functions, and since we have the same base logarithm and the same base exponent here, we can actually cancel these out and we'll just get log x minus log y. But let me show you why over here. If you had let's say you had log base 3, just this is just an analogy over here. So say you had log base 3 of 3 to the 4th power, and that equals what? Well, that's the same thing. That's the same thing as saying 3 to the what power equals 3 to the fourth. Well, clearly, in that case, x is equal to 4, because it's just like with like. 3 to the what equals 3 to the what. So we actually have the same case over here. When you have a logarithm with a base that's, and you're taking the logarithm of an exponent with a like base, you can actually just cross out, these 10s here, and you're just left with log x minus log y as the answer. So we have log x minus log y, no longer in an exponent, and log base 10 is, like I said earlier, the shorthand for that is just log of x over y, which is the same, this is log base 10 of x minus log base, oops, I made a mistake, log minus log base 10 of y equals log of x over y. And finally, just because people generally write it this way, so I want to make it easy on your brains, it's log of x over y. We're just switching the right side to the left and so forth. So log of x over y equals, and I'll just copy and paste this, log of x over y equals log of x minus log of y. And we are done.